Mean value theorem is my favorite thing in the whole class. I'm totally kidding. But the best way to learn theorems, in my opinion, and this helps in college, is if-then statements. If something is true, then this happens. Okay? Pythagorean theorem. If it's a right triangle, then a squared plus b squared equals c squared. Turn them into if-thens. Okay, then it makes theorems a lot easier. So that first one, it says, if f is continuous and differentiable from a to b, then there exists a point C, so between a and b, such that the derivative at that point is equal to the slope of the endpoints. What? That's crazy. Can anyone visualize that in your, oh, you watched the video, so hopefully you have some kind of visual in your head. But if you don't, here's what I'm going to show you. So I have this graph right here, and it's on an interval from a to b. Okay, it looks like it goes from -2 to 2. Now what you can do is you can imagine the slope between the one endpoint from the left to the endpoint on the right. Okay, it looks like that. Okay, so I have the graph and I just made a slope, a line that connects those two. There is a certain slope, you should be able to find that, right? The coordinates are there, you should be able to find the slope. Now what mean value theorem states is that there is at least one point, there could be two, that has the exact same slope as the endpoints. So you see the green line there? You could probably visualize where those tangent lines are. And if you can't, then you probably didn't watch the video, but here's one of them right there. If you notice, those lines are parallel. Okay, now there's another point in here, but I programmed Desmos to only find one because, I don't know, I just didn't go through it well enough apparently. So I'm gonna actually show you where the other one is, and it's kind of a good exercise to be able to do this anyway. Okay, there is another point that has the same slope as those two lines there. Can someone tell me about the range of where that is? What x value it's around? Go. Yeah, between -2 and -1. There is going to be another point that has the same, this is going to be really right there, maybe, okay? Right there that has the same slope as the endpoints. It's called mean value theorem because on average, the average rate of change between here and here, the average rate of change, there is a point where it's equal to the instantaneous rate of change. So the average rate of change from the beginning to the end, there's certain points where it has the instantaneous rate of change and it's the same thing. That's a huge concept. If you want to think about it in terms of like the real world, and you were traveling 50 miles, point A to point B, this is 50 miles. Okay, from point A to point B. And just for the sake of easy numbers, we're going to say it took 1 hour to do that. So on average, you went 50 miles in 1 hour. Now, does that mean you were going 50 miles the entire time? Could it though? Could it mean that? Yeah, it could, but chances are it's not. Okay, you stopped, you turned, you slowed down, you sped up, whatever. But on average, it was 50 miles an hour. Mean value theorem states that if the average 50 miles per hour from A to B is true, which it is because I just wrote it down, there is at least one point in there that you were driving at least 50 miles an hour. Okay, you could not have been going 100 the whole time because then the average would be off. You couldn't have been going 10 the whole time because the average would be off. There was at least one point in time, one instance in time where you were going 50 miles an hour, unless you teleported or something like that, okay? But then that wouldn't be continuous. And if you remember, for mean value theorem, the first if statement, it says if it's continuous. It's not exactly continuous if you go from point A to point B and there's nothing connected, right? So hopefully that makes sense with what mean value theorem is all about, okay? Now, you might think, oh, this totally makes sense, you know, great visual up there with the graph, Mr. O. You know, you have a great example with the average thing. This makes sense, but when you see a problem, to apply it is very difficult. So make sure you have it down. And you might understand what I'm saying, but to apply it is a whole other story. It'll make sense when we do example problems today. But the main thing is the average rate of change has to be equal somewhere to the instantaneous rate of change, but it has to be continuous and differentiable, okay? Let me show you an example of one where it wouldn't work because it's not continuous or differentiable. So say I graphed this. Here we go. Let's graph point A to point B here. And I'm going to do this with an asymptote. Don't write this down. I just want your brains for right now. Oops, that's kind of embarrassing to hear. Let's do that. Okay, now if you notice, the slope between these is right here. But there is no tangent line that has that same slope, okay? Remember, tangent lines just graze a point, so you can do here, nope, here, nope, here, nope. There's nowhere that you can do it. So because of that, mean value theorem does not apply. It has to be continuous and differentiable. And sometimes AP tries to trick you by making it so it's not continuous, and you don't realize that at first. And you're like, oh, shoot, I didn't realize that it wasn't continuous, and then you get the problem wrong. So long story short, the first thing you should always do is make sure the theorem is true. If is it continuous, is it differentiable? All polynomials are differentiable. You should know that. The things you're looking out for differentiability, continuity, is divisions by 0, because that would not be continuous at that point. Mean value theorem. You'll never see me actually write it all out. I always just write MVT. All right, this is going to be crazy. I'm actually going to write down the words for this because AP follows a very strict wording for this. It usually says something to the effect of, if C is the number that satisfies mean value theorem, satisfies the conclusion of mean value theorem, for f of x is equal to x cubed minus 2x squared on the interval from 0 to 2, then C is equal to what? Oh! Okay, many different ways of thinking about this. If you want, you can graph it out. So yeah, you can graph it out. Probably the easiest way, the most straightforward way, is to do this algebraically and just think the IROC has to equal the AROC. Okay, so somewhere the derivative has to equal the average rate of change. So first thing let's do is find the derivative at C. Okay, so what is the derivative at C? Well, let's find the derivative at x first, and then replace all the x's with C. So we have something like that for the derivative, straight up power rule. And that means f prime of C has to be equal to this. Now, obviously, you could have just written that red step with the C right away. That's what most people do. Sometimes I forget to plug a C in and just use X. It doesn't even matter. But the problem asks for C, so I decided to use that. Okay. We are going to set this equal to, remember, this is the instantaneous rate of change. We need to set this equal to the average rate of change. So we need to find the slope from 0 to 2. Okay, from x equals 2 to x equals 0. So on the bottom, the change in x is going to be 2 minus 0. But we need to plug in the 2 up top in the function, and then the 0 as well. So really, this is just the yellow right there is just the slope equation, stuff that you've seen from Algebra 1. So let's see here. What is f of 2 equal to? Anybody? Just yell it out. It's equal to 0. What's f of 0? 0 divided by 2. So now we end up having 3c squared minus 4c is equal to 0. So now the last thing we need to do is just solve this out. I would solve it with factoring, I guess. Is equal to 0. So you end up with c is equal to 0 and 4/3. But it's a trick. What's the trick? Does anybody see what it is? You really have to understand what mean value theorem states for this. You know the trick? Oh my, you are a genius. Holy cow. You don't understand how many times that trips people up. That is amazing. The point C has to be between 0 and 2. 0 is not between 0 and 2 because it's on the endpoint. So you actually cannot include that. And yes, that trips people up on the test. Part of the reason I'm showing you this. So the final answer is actually just 4/3. And you have to always check too, is 4/3 between 0 and 2? And hopefully you see that it is, because it's 1.3 repeating, but crazy. By the way, that just so happened to be where the derivative is equal to the slope, and the slope is 0. The slope could have been 5, it could have been 10, it could have been any other number. It just happened to be 0. So just be aware of that. It's not always like this 0 here. Be any other number. In fact, it's usually not 0. Okay.
But in the problem, it says greater than or equal to 0, but that doesn't matter.
No, because if you go back to mean value theorem, what that theorem actually states here, I'm going to pull it up on the screen right here. It says, if it's continuous from A to B, there exists a point such that, it has to be between. Long story short. Another way of looking at it, I'm sure you're going to say it, or you're going to say, go ahead, say it. It's not differentiable at 0. Exactly. If you notice right here, and I did this on purpose, it's a parentheses. Okay, so if you put C in there, if you put 0 in there, you can't include it. It's not differentiable because it's not differentiable at an endpoint. Dude, that's awesome. Very good. I'm sure you're going to say the same thing, maybe, Jonah. Does that make sense, Quinn? If that was Quinn?
Yeah, I get it.
Sure. Cool. But yeah, don't get tripped up. It has to be between. I should have wrote that in there. C is in between A and B. Cannot be on the endpoint. Okay.